Hi everyone, welcome to another Wolfram language design review, kind of our second for the day actually, part of our language completeness and consistency series, and let's start off with Cyclic.
Right. So we have a draft rough page to review. Well, I last touched it a couple of weeks ago, so I presumed
I'm sure it's gotten updated. Okay, gosh, really you have to have that complicated an example to begin with?
is it really that complicated?
Well, but aren't
That
we using Cyclic in some simpler case with just,
the fact that it uses coloring, I think, implies that it's a bit complicated.
yeah, and I mean, I don't understand why isn't this
I
extract
mean,
the case
we
element
we,
in a site? Yeah.
we
Oh,
well
what
we
is this?
invented it specifically because you were complaining about grid.
No,
So
I understand that, but I mean, I think that it is potentially has much wider uses. I mean, you're saying if I say cyclic ABC,
right. I mean,
and
that's
then
like the second or third basic example. If you want that to be, if you want me to move that up to the first
I
example,
think it
I
really should
used
be.
I made the first basic example correspond to the first usage rather than the second usage. That was my only thinking there.
I
Um,
see. I just think that this is a clear, this sort of explains what it is, so to speak. Um,
okay.
and I mean, I think it is somewhat interesting to see, this presumably will work, right?
Mm,
Just works.
That might read more easily as a table.
Yes, it might. I mean, I'm not suggesting so. So let me just understand in terms of. I mean, honestly, I think this function is going to be really useful, and it's not just for. Let me see. Does this work? Oh yes,
yeah.
very
And
nice.
those are all in basic and scope examples.
Yeah, all right,
But
fine, fine, fine,
there's a
fine. I'm just
table
complaining.
example illustrating things.
Um, well, I like this function. I mean, did we think about a 2D analog of this function, or is that not useful? I think it is useful. I mean, that's kind of like a
Well, we uh, considered and rejected it.
okay. Well, let's get the 1D one in first.
Okay. Right. So one question is, and John sort of copied this verbiage from up to, right? The first usage line is, cyclic of blah is a symbolic representation that represents a stuff, and we're wondering if we should shorten that to just represents,
By the way, it's good that this doesn't work because that gives us an opportunity to extend to the multidimensional case more
right.
plainly.
Anything that's not explicitly an integer just returns unevaluated.
Okay.
Um, so right. So basically, I was thinking delete everything in that first usage message that comes before represents.
Yeah, I think that's fine.
Okay. You can make the change, or I can make the change later.
No, I'm not going to make the change because it's going to mess stuff up.
Okay.
All right, this looks good. I mean, I think that, yeah, I mean, to my mind, up to has been a huge success. I think this can be a similar success.
Mm-hmm.
Are there like thousands of places where we need to add support on the right-hand side of rules and things like that? Or will it just work everywhere we want it to work?
I don't know. I think that's worth looking at.
I mean, there will undoubtedly be places where we need to add support, right? Like sort of anywhere in the front end, it will need
Yes.
that we want it to work, we'll need to add support. We sort of decided not to do anything with part for now. And there will undoubtedly
Yes. So I'll give you an immediate one. This is for Brett. This is something where if we have a list of plots, and we say, you know, plot style, arrow, cyclic.
I was just thinking of that as, you know, part of the list disambiguation, you know, like we use directive for as well.
Yes,
Um,
that's a good use case.
Try
I think
that. See, oh, well, I mean, you'd need to change the functions, but I'm wondering if it would just work, or if it really, probably the plot parser needs to
no, I mean, probably, you know, because it's not list, plot's going to try to treat it as a directive or something, and
Right.
it'll end up falling back on the default sequence of colors.
yes.
yeah.
What about like inside thread when things aren't the same length?
How you'd use it there? How would you use it there?
So like, you know, you have thread of ABC, the list ABC equals the list 1, 2, 3, 4, 5. If you wrap the ABC in cyclic, then
That would be nice. That would be very nice. I think that's a luxury, but it would be nice.
yes.
We should continue brainstorming where cyclic could be used. I mean, I'm just look, I mean, there are places where in a list plot or something. I know that's not a good case.
Is there a
Discrete.
use case of cyclic with an integer argument used in the same way that up to is used in like part specifications?
We specifically rejected that.
So
it's
far.
something we can go back and reconsider that in the future, but
well, I think we should get on to our next topic, but I bet there are cases in partition, for example. You know, I'm disappointed that I haven't been using threaded as much as I would like to be. Just not quite used to threaded. Okay. All right, let's move on. Telemetry. Okay.
yeah. So I'm not totally convinced that this is a useful thing, and you know,
Well, I'm going to tell you that everything we've added, that is, I mean, whatever happened to monitoring with map?
that's a question for Julio.
That's in Proto.
Oh, it
That's
is.
right.
Let me see it. Let me see it. Let me see it. It's exciting. Okay, here. So if I say monitor, and then I don't know, factor integer /@ table, I don't know. Factor integer of I don't know what. Give me something reasonable here. 2 to the hash minus 1. Well, that I'm just going to ignore that caret right now, right?
Yes.
This is because we is not in system. Too fast.
That's beautiful. That's wonderful. I mean, there were aspects of that display that I wasn't that keen on. Let's go with something harder here. This is really ugly. I mean, something like this is good. We have got to fix the short business. Also, is there any good reason why we don't allow a kill it button here? Why not put a kill button?
You rejected that. You wanted only stop, not abort. When we designed the progress monitor indicator.
No, I understand, but that was for the progress monitor for other things. But in this case, it seems like, you know, with a tooltip that says you're going to abort, I don't see why you shouldn't allow abort here.
Well, I mean, the infrastructure is there. We need.
What other functions does monitor here?
Table, map applied, apply, fold list, nest list. fold. I mean, there's a. I can give you a list.
This is great. This is really good. Really nice. Wow, it thinks it knows how long it's going to last. Well,
Well, this will miserably
It's going to be
fail.
wrong on this one.
Element takes
Yeah.
the previous one.
Yeah, it's going to be like my time machine backup, where for the first 4 hours, the estimate keeps growing, and then at some point it's like, oh, okay, I'm done now.
what are we doing here? Are we assuming equal distribution, or are we trying to do something a
Yes.
little cleverer?
No, I could, now that we're using this for more and more things, I could go back to the to this and try to do maybe small fits.
I think we should do that. I think it's useful. I mean, I use it all the time with parallel computation, and it generally does well. But and sometimes it can't possibly know.
Yeah, I mean, I'm sure there's some famous halting problem corollary that
There is.
possible. But
I can tell you, I can easily make up functions for you where it's hopeless. But in other cases, I mean, this one
doesn't imply that there's a very
Sure.
reasonable subset where it can do well.
Should you just use a multiplier based on prior delays?
What does
Like
that mean? I
at-
mean, if you look at this case, okay, if
Well,
I
at
look
213th element, it took a very long time. So maybe based on how long that particular computation took, instead of adding a constant amount of seconds, add some multiplier.
I mean, which is analogous of doing a nonlinear. I mean, right now it's doing a linear fit, yeah, which is wrong every time, and more wrong the more it departs
Right.
from the origin.
well, I mean, you have to look at the variance. I mean, in other words, here, if we gave plus minus some number or something here that indicates the variance, that might be a good first approximation. See what I'm saying? So in other words, you do a fit. It's a linear fit because it's just, a number of items so far. How long did they take? But then if you compute the variance of how long they took and then use that to estimate the error, I think that will be a reasonable piece of UX.
I could, sorry, I can try something and put it in, and then we review that.
Okay, right, but the shorts here.
That's shallow, and I'm not sure. Do we have a better way of doing that?
Look, I don't mind the output. I just think maybe we just need to change the visual appearance of those angle bracket things, which come from version 1, guys.
Well, technically version 3, but
Okay, that particular one, version 3, but the idea of angle brackets 1,
yes.
that's my code, or it was my code at one time from version 1. Look, maybe all we need to do is to change the graphical appearance of this. And maybe that's let's try for that first. Does that make sense? So let's get a meeting where we have design folk, which we don't have at this meeting. Okay, so this type of monitoring is, so first question is, if an LLM is going to see this type of monitoring, even this type of monitoring, I mean, let's imagine that you just put a great big monitor outside everything when you want to get telemetry. Where does the telemetry go? What will be useful to an LLM that's watching what's happening?
It's kind of hard to say. Like, I mean, in this case, one thing that would be useful is like the timing, seeing how it's increasing over time. Like, and then the LLM could explain that, why it's increasing, for example.
I think what Michael has in mind.
No, exactly. That was not the scenario I was thinking of.
Yeah, I was hoping you would speak up and try to convince me why this is at all worth our time.
Okay, so the current LLMs can write quite remarkable code basically beyond what I could write in the same time. non-trivial code that really does non-trivial stuff. But then when the LLM runs it, sometimes things go wrong. And for a variety of reasons that even we couldn't always foresee. So giving the LLM, especially because the LLM typically writes very nice modular code, so a certain function definition with a module which has a compound expression of 12 things inside. So giving the LLM a handle where it is right now and what had happened so far, message-wise, will be very important for the LLM to know
what
what
does that,
potential
yeah,
change.
yeah, well, that's where I'm going to challenge you right there.
Yeah.
What does it mean where it is right now?
Like in like the typical case I feel is we have a function definition, f of x colon equal, a module on the right-hand side. The LLMs really like to encapsulate very well. And then there comes a compound expression. A equal this, B equal this, blah, blah, blah. In which of the elements of the compound expressions it currently is?
Okay, right. So that's I mean, I suppose it's not a completely different thing, but that's certainly a very different thing from, you know, the progress reporting story where, you know, we're saying, you know, we're inside this function and, you know, we've done 8 units of the 20 units that we're going to do, or, you know, we're trying this method.
Right, right. This is different, yeah.
Sounds like you want to send an update every time the stack is updated, or, you know.
Well, hold on. So this is an example of where something went wrong. I mean, I didn't know to pick this, but okay.
Okay.
And Brett, what the heck is this?
I don't know.
Where's that?
You
I mean,
could,
that
I don't recognize the function off the top of my head.
just for fun, try asking Notebook Assistant. It should actually be able to see the stack trace.
Be surprised if it could.
Well, actually, because that's like internal code that generated the message, it might not see enough info.
As a first start, I would wrap and evaluate around the first argument of plot.
yes.
This is the single most common mistakes LLM currently make in writing writing Wolfram language code.
Not putting the evaluate inside plot.
Not knowing when to need the evaluate.
Yeah, I understand.
No, this was not the problem here.
Okay. In any
This
case,
might be a bug in prototype, right? Because
oh,
It's
yeah,
possible.
Right.
Yeah.
Yes, that's possible.
I don't see anything obviously wrong with this code. So
Okay. Well, the humans are stumped. Let's see.
Don't admit that to the LLM. It's a sign of
Yeah.
weakness.
Stephen,
No,
can
you
you?
were right. It is a prototype problem.
Okay.
Okay, so this isn't a great example then, but I mean, it sort of was an example, but it wasn't an example.
It
Where-
wasn't really a good example because de facto there was only one step that did anything. The other steps were all definitional and didn't do anything.
All right, so give me an example. Let's just make an example where it does something more. What's a good? I don't know.
Let's try build me a Hofstadter butterfly. At a
Build a what?
50%. A Hofstadter butterfly, it had a 50% chance of working.
I don't know what a Hofstadter butterfly is.
It's the energy spectrum in a crystal under magnetic field, because the magnetic field spectrum.
Is that?
Oh, we have a built-in function potentially.
Or
Yeah,
Beautiful, but
exactly.
that doesn't.
Yeah,
Okay.
good.
Do that not using the resource function. Can it see the source of the resource function, by the way?
No.
Not in the rag now.
Okay. That looks interesting. That's rather impressive. If it didn't already see, if it didn't see that in some example somewhere. Help! What's it doing? Well, that's your point, Michael.
That shows now the point. Basically, what it didn't do right, or not perfect, is it shouldn't try to get symbolic eigenvalues.
That's the problem.
It should make eigenvalues of n. That is a,
Yeah.
but this is a good example for my point.
Yeah, that's
Right.
exactly the issue.
I know, I understand, but the question is, right now, this should be flashing up, computing eigenvalues, symbolic expression, whatever. That looks more like a butterfly than this.
Yes.
But Michael's point there was, while it's just sitting thinking for a long time, well, okay. So first point is, when it generates an error message, right now, we have the information of where that came from stack-wise. True or not true?
Yes.
Okay. So there's nothing in terms of where did something go wrong? That's reasonably good information. Do you agree, Michael?
Yeah.
Right.
If the information is better than the information that associated with the message, which is too often still general colon.
So I think one of the things you're talking about is the idea while some code is running and seems to be stuck on something, could you ask an LLM what it's doing, like what the current issue is? Is that
that's one thing, but I actually want to go back to Michael's previous point about general messages. Michael is making the point that we have too many messages that are still not properly localized to functions, but maybe that's not such an issue if we have the stack trace information. Comments?
So two comments. At least in my code, I don't encounter general that often, and typically when I do, it's in things that it really should be general. Second is, we have the stack assuming it hasn't been pruned, right? Right. You didn't want the message stack to include everything. So by default, we prune anything that has, I think symbols other than system and global in it or something like that.
Right. I mean, there is a possibility that we could give. The problem is, we don't want to spew out a bunch of internal stuff that will just confuse the heck out of people. But the LLM conceivably could read some of that stuff. I mean, we could conceivably feed that to the LLM.
Right.
Let's address that question for a second. An unsanitized stack for the LLM. Would it be useful? Would it just confuse it? Or could we give it prompting or something around the unsanitary parts of the stack that would make it do something useful with them?
Well, it already sees prompting that when it sees a stack trace, it knows that it's not visible to the user. So I think it should just work if we give it.
No, but the problem is, Rick, the problem is it's going to be like look at what happened wherever it was when we had this, okay? Legend dump, remove wrappers, which is something in the prototype build.
The stack trace it sees should be the same as what you see if you click on like the 3-dot menu next to the message.
I understand that that's what it is right now. What I'm saying is that the other possibility is that it sees more than that. Because right now we are not showing the parts of the stack that are essentially an internal code.
Right.
Okay.
Whether or not that's helpful to the user, I don't know.
No, it's not helpful to the user. That's why we didn't do it. It's
nothing
completely confusing to the user. But the question is it helpful to the LLM?
That's what I'm wondering. My first thought is no, because what would the LLM do? It could suggest that there's a bug in this particular internal function because it's doing this or whatever, but what's the user supposed to do with that information?
Well, that's the question: is whether there is a way of taking the internal stack trace, which probably isn't a bug in the internal function, more. Well, what would it tell you, Itai, or somebody like or Danny? Do you have a comment on this? Is there something? I'm trying to think. The internal stack trace.
I don't know what it would make of internal things going wrong. One of the things that it sounds like you're asking about also involves not just what's going wrong, but where is it spending its time? And for that, you need not just a stack, but some temporal notion, like,
I
how
understand.
long have I been here?
That's the next step. Let's just talk about the pure stack trace question for a moment, and then let's
Right.
talk about the time being spent.
Right. So, when I turn off the pruning, right, there can be two reasons I do that. One is it's my internal code and I want to see where I screwed up. But the other reason is sometimes it's not entirely clear which part of my input is generating the message. And by seeing the more complete stack trace, I can, work backwards to, okay, this is a bad message, but actually I screwed up here. And, if I fix this part of my input, it'll be happy. How that translates to LLMs, I have
If you
no
remember, Itai, the next time you see a thing like that, can you capture it and then we can talk about it?
Sure.
Because I think I think we need some examples. I don't think it seems to me not at all obvious whether this. So the question is, you throw something gets into an internal function that isn't quite the right thing, okay? And possibly the internal function just knows to reject it by virtue of its error message, by virtue of input processing error messages. But the other possibility is it gets into the innards of the machine and something then goes wrong. Do you see what I'm saying?
Yep.
And that it wasn't caught on the net when it went in, so to speak, but it then ensnares horribly inside.
Yep.
And in a sense, what was wrong was that you fed the wrong thing into the function, but it just didn't have the right netting on its inlet, sort of manifold or whatever to
You see,
to deal
you're
with
asking about two different things, I think. One is how can the LLM be used by the developers to debug, and the other is how can it help a user to fix their code,
No,
possibly written by the LLM. These are not the same thing.
The developer debugging is not. You mean internal developers?
Yeah, if it's getting lost in an
thing.
internal functionality like this prototype build is, you can't tell the user anything other than it's a bug, file a bug, or something like that.
Right. I mean, the message the LLM gave for that was, I think, about as good as it could.
Yeah.
It's like, there's an error there's an error in the legending, framework somewhere.
Right.
Which is decent information for the user because it tells them, I don't think it's the code I wrote for you, buddy. I think it's their code, our code, that is.
But the case I'm talking about, which may or may not be a significant case, is, sometimes the input doesn't have the right form. We know that immediately. We produce a message. Sometimes the input to a function passes our initial input tests, but then when it gets inside the function, something goes horribly wrong.
Well, that's what happened here.
Well,
this prototype
build.
Well, no,
not horribly wrong, but wrong.
No, but maybe, for example, it turns out that there's a numerical, I don't know what.
So here's an example for you, Stephen, that I came across today. I think Stefan reported it or something. Do list plot of 1, 2, 3, comma overflow. Right. I mean, that's a case where the safety net failed.
Yep. Now I wonder what the LLM would say about that.
I bet it doesn't say anything about it.
You don't think it'll say, "Oh, bad idea"?
Well, I mean, I
it
think
might also
that particular
say, might also
message.
get ensnared with its own iteration limit. I don't know.
Right.
Right. I mean, I think that
Right. So
that
the
message
problem,
is like,
right? The problem is that overflow is a real, right? So it's not, or,
oh, nice.
It's really not bad.
Extremely nice.
Yeah.
I'm impressed that it caught the issue with overflow. That overflow is the issue.
Yes. Okay, look, I think it gets a gold star for that. I don't think we need to worry about this. Okay, let's talk about the other thing, which is it's taking a long time. What's it doing?
So that's what I was kind of starting to talk about. Like while something is running and is maybe stuck, the idea is you want to ask Notebook Assistant what's happening, right?
Mhm.
So currently Notebook Assistant runs in the same kernel, so that wouldn't work with the way it's implemented, but it could conceivably work if it was running in another kernel. Sorry, and it preempts the kernel that's running into a subsession to retrieve like the stack.
Yes.
Something like that could work. I'd have to think about it a bit more.
Well, if it did that, I mean, that would almost seem like that's the story. But by the way, can I do that? Let's see. I never use subsessions. Let's try. That was my.
I
I
wonder if
believe
this
you
could be done
removed
with
the
a
menu item
task.
that does them. I mean, you still can do it if you know the secret shortcut, but I believe we hid that.
Which, well, I don't know how well it worked. I mean, you're saying here, if let's say I do this, right? Now, how do I interrupt here?
I think it's F7, at least on Windows it is. I don't know. Like if you want to
John,
evaluate.
what's the interrupt on Mac OS?
Command, comma,
Yeah, command,
Period.
command, comma.
No, that's
No, that's
bold.
preferences.
yeah, I think it's command, comma. Yeah.
Well, it wasn't command, comma, because
Uh-oh.
command, comma brought up preferences.
Oh, sorry. Let me look it up real quick.
Is it still documented? Because
It's command
not in the
option
menu.
period.
Yeah, I got a spinning disk here. That's not encouraging. This is why it isn't documented anymore. What the heck do I do now, John?
well, probably abort.
No, then I'm dead.
Well,
No.
yes, but I think the
Yeah,
problem,
well, I mean, this is, I mean,
well, I think the problem is the dynamic. Right.
this is a hard situation because you interrupted a thing which then has dynamic outputs that is still trying to populate there.
Well,
It's
let me
it's
try
not a
doing
good
this without the
situation.
monitor.
Is that a prototype build still?
Yes.
Yeah, okay.
Let's try doing it without the monitor. Okay, just sitting there. Command option period, right?
Yeah.
Oh, that's exciting. Okay, now I can go enter subsession.
Yep. So now if you
where's the subsession?
it's there, if you move and start evaluating, you'll see that
Oh,
the
okay. So if I say stack, for example, that's not bad. Now, is there a way to poke the kernel process and have it disgorge the stack without having to go this deep? I mean, this is the evaluator stack, so it's not obvious that not everything will be on the evaluator stack.
So the short answer is I'm not sure there's anybody who can in this meeting who can easily answer that question. My guess would be no, but I would have to talk to Tom about it.
Okay. By the way, does anybody have the slightest idea what Wolfram provider definition
Yes.
registered means? What is it?
There is for remote batch submit. I have no idea why it is appearing there with no prompting.
The assertions are a recent regression. I have a fix in pull request for them.
Fine. Okay, but so if we could get to a subsession, then we could get something very reasonable that the LLM could use. Fair statement?
We could get some information. It wouldn't have a full picture of what's going on. Like if you're just looking at the stack, you don't see you just see the path going up to the top of the evaluation tree, essentially. You don't see the stuff like adjacent to the current.
Well, you could if you looked at the code. I mean, if you compared the stack trace with the code that you're running, the LLM might very well be able to thread the stack trace through the code, so to speak. We could probably do that.
Yeah, assuming it's all deterministic.
Yeah, I mean, look, it could generate code on the fly, but that's the life of a machine learning system, so to speak, is it's dealing with smooshing around those kinds of issues. Most of the time that won't be happening.
It won't have timestamps, right? You can't get that just from the stack, can you?
I mean, if we had something like
you have to query it,
like some structure like trace graph gives you, but like in the middle of an evaluation, shows stuff that's already done in the evaluation tree, like when it happened, maybe with timestamps, and stuff that isn't done yet marked separately. Maybe we could give even more information, but I realize that would be.
Well, the point is that stack is stuff we already have. I don't know whether we have anything else that is already there that is just for the querying, so to speak. So I'm saying, I mean, for example, this is something we record in the top level loop, right? I don't know what does that even mean in the case of a subsession? Anybody got any idea? I should use subsessions.
Try evaluating it again. How much did it increment by?
Evaluate what again? Oh,
time used.
Time used.
It went. Oh no, it didn't.
So it's not incrementing by clock time, but something.
No, internal evaluator.
Time. Yeah.
Presumably, what timing might give.
Oh, it's time used in the session, so it's global for the session. It's not used. Okay, so I'm just to recap, and then we have to wrap in a moment here. But for Michael's purposes, the main thing is to let the LLM know when there's a computation that's taking a long time. Tell the LLM what's going on. Is that a fair statement?
Yes, and I was even looking more in the future than Rick, where we have the case a human is trying to achieve something. I was really thinking a year from now where the LLMs, a bunch of them operate in some agentic way to make some coherent research on their own, that they basically have at each moment an idea what happens and recognize what has to be changed, potentially.
Yeah. I mean, they're writing code, but I mean, look, what we humans do most of the time is we see what the output is, and then we look from that. Okay?
Exactly. And we let's face it, if we do this ourselves sitting in front of a notebook, we use interrupt quite a lot because something didn't work, and then we look what went wrong.
Yes.
And we use print statements and see where we are dynamically, so to speak. I know.
Half a century ago, the first computer I used had a tone generator, and you would run it, and it would make weird noises depending on what it was doing. We tried something similar in version 1 or 2 or something. Was not very successful. I don't think people like that anymore. Back in the day when there were still toggle switches on the front of the computer, it made more sense to have it make a noise.
I just posted a function in the function repository that I've used before, but you have to know ahead of time that you're going to be doing this sort of telemetry. Right? You can't do it after it's already taking a while. You have to know from the outset, kind of like a monitor. Right. So
what Rick was.
Yeah. Yeah,
Well,
so
Rick
you
was
can,
talking about with a different kernel, you could poke this thing on a regular basis every
Right.
whatever. And if the stack hasn't
Right.
moved after a while, you know you're stuck somewhere and you know
Yeah, but
where.
Rick, how does
Right.
this work? Evaluation timing. What does it do?
It's been a very long time since I wrote that.
I think it's hold all complete, and it like has a pattern, and every time it sees one of those heads, it wraps it in like absolute timing, and then
yeah,
puts it in a bag, and
it's
then
just
it
a whole bunch of metaprogramming stuff using,
Yeah.
I believe, like trace scan or something like that to just attach evaluations to every sub evaluation to
I see.
record the timing.
and it's really only useful when you give it patterns to look for. But
Well,
if you
so
do that, then it's really useful.
okay, so look, the fruit that is not totally out of range, in my view, is poking for a stack trace. These other things that involve, I mean, there are a couple of things. First of all, for the agentic use of essentially Wolfram engine, the ability to do an interrupt from the LLM seems useful to me.
Yeah, that's something I've thought about. It's a little bit
Actually,
difficult.
there's a simpler way to think about this, if I might say so. I mean, if the LLM kind of routinely wrapped time constrained around things, if it said, oh, I think this is going to take 30 seconds, okay, wrap a 30-second time constraint around it. Possibly with an additional argument that shows the failure in the case where it blew out of the 30 seconds. Because
Yeah,
I don't think we've ever asked the LLM, because it has no idea how long things take. I mean,
yeah,
we could.
I don't think it would come up with a good estimate for that. What I did for the evaluator tool that the LLM uses is I just gave it a 60-second timeout, which is unfortunate if you're asking it to evaluate something that should take longer than that, but it's kind of just a simple heuristic because it's really not good at estimating the time.
Okay, but let me make a suggestion. We could make it good at estimating. We could generate a data set that is, for example, millions of QA tests run with timing. We could give it some idea, just like we humans have some idea. I mean, that's just not information that it ever had the opportunity to know, but we could tell it.
I mean, another approach is to start the evaluation with the code that it wrote, and then every so often maybe we have like a scheduled task that preempts to check if it's still running, and if it is, it sends that information back to the LLM saying it's still running after this amount of time. You can either continue waiting, interrupt, or do whatever.
No, but as you say, it has no idea how long these things should take. I think it would be interesting to try and generate a data set of time estimates.
Well, to an extent. I mean, if I think it'll have a good idea of when something should be nearly instantaneous, but it happens to be hanging. I think that's a case where it would be obvious to the LLM that it's something that it should abort and then figure out what the issue was.
Yeah. I mean, that's what I'm saying is that things, I think it would be an interesting thing to try doing, and the QA group could potentially generate that data set of here are a bunch of timings for just lots of things. We could just run the documentation examples and see how long they all take, and then feed that to the LLM and have it try to estimate the timing for a new function. I don't know how well it will do at that, but it will be an interesting experiment to try, it seems to me. And then given that, based on well, I don't know whether that's enough for it to, in its agentic operation, well, this is maybe a question for Michael. I mean, what would it, when we do things, it's like we have some idea of how long we have an idea whether the thing we're about to do is our big production task that's going to take a while, or whether it's a little experiment that should come back quickly.
Right. And I think the LLM has an incline on this. I have frequently seen the LLM saying, I make a small table because this takes long and such things. So it's not totally clueless about this.
Yeah, I mean, it's so often wrong, though, about a lot of things, though. Like one of my test cases is asking for, the nth prime with some very large n. And it'll frequently say, okay, I'll evaluate prime of that number, but be aware that this will probably take several minutes or maybe even hours when it's like a few milliseconds in reality. It
I
can
know,
just
that's why we should try the experiment of giving it a data set of actual timings.
It's a good idea, I think, but it would take a lot of work.
Well, I'm just suggesting we might try the experiment of taking examples from documentation and just generating a data set from it and just feed it that. It may not work well. It may be one of those things that's basically a computational problem and it just doesn't work very well.
Yeah, and even that data set, I think, could have other useful applications aside from experiments.
Fine. I mean, you know, the thing that we like don't have in documentation is any kind of thing where we say, you know, a rough time estimate of this function is blah, 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 because, you know, that's been a moving target. It will continue to be a moving target. But, you know, it was an n squared algorithm yesterday, and now it's an n log n algorithm type thing. But I mean, I think if this is, look, there seem to be 2 points. One is poking for a stack trace, and the other is kind of getting a preemptive time estimate. Because, you know, well, okay, there's a different issue, which is as a human, I'll try something, and if it doesn't work quickly, well, I guess this is the LLM can do the same thing. If it doesn't work quickly, I'm going to give it up. And similarly, the LLM should be, you know, hey, let me try this, but it's supposed to be quick. I don't think we're prompting it to try and do it that way. All right, I think I should run along here, but to be continued. I mean, this is we've had some decent ideas here, so let's take it from there.
I don't think we want to teach LLMs how to become impatient. They might become impatient with us.
I like that. It puts up a dialogue and it starts saying, you know, whatever. Okay. All right. See you guys soon.
Yeah.
Bye.